students. So last class I have discussed about center of mass, the position vector of center of mass, and today I will discuss about velocity of center of mass and acceleration of center of mass. Okay. So first of all, let us discuss velocity of center of mass. Velocity of center of mass. Now, for a two-particle system, the position vector. So yesterday, in the last class, I have derived the expression for a two-particle system. The position vector of center of mass is what? M1 R1 plus M2 R2 divided by M1 plus M2. Okay. So this is the position vector. So what is the velocity? So V, center of mass, V we know it is dr by dt. So d RCM by dt. So just to differentiate it, okay, d of dt, it will be what? M1 R1 plus M2 R2 divided by M1 plus M2. So this you can write M1 plus M2. Here M1 you can take common, dr1 by dt plus M2 dr2 by dt. So we know dr by dt nothing but velocity. So this you can write M1 V1 plus M2 V2 divided by M1 plus M2. So this is the velocity of center of mass. So you see having similar expressions in position vector, you have M1 R1 plus M2 R2 by M1 plus M2. In velocity you have M1 V1 plus M2 V2 by M1 plus M2. So having similar expressions. Okay. Now if we extend it for n particles, okay, therefore for a system of n particles, okay, n particles, you just extend it, okay, you just extend for n particles. So it will be what? For a system of n particles, the V center of mass, you can write M1 V1 plus M2 V2 up to Mn Vn divided by M1 plus M2 up to Mn. Okay. So this is the velocity of center of mass for a system of n particles. Okay. Now from this relation we can extend it. So this you can write, you see, M1 plus M2 up to Mn into VCM equal to M1 V1 plus M2 V2 up to Mn Vn. So this M1 plus M2 Mn means total mass. Total mass you can consider M, capital M. So VCM is equal to M1 V1 plus M2 V2 up to Mn Vn. Or this is nothing but total momentum or momentum of center of mass. This you can write M1 V1 plus M2 V2 up to Mn. So this is very simple, just you have to follow the steps carefully, okay. So total momentum of center of mass, you can write M1 V1 plus M2 V2 plus up to Mn Vn, means that is the individual momentum of the particles of the system. So this is the equation, velocity of center of mass for a n particle system, and this in terms of momentum. Okay. So similar way you can find the acceleration of center of mass, exactly same way, just by differentiating velocity. The next, acceleration of center of mass. acceleration of center of mass. So acceleration of center of mass, this is what? d VCM by dt. So here you put the value of velocity of center of mass. First you put for a two particle system, then you extend it for n particles. So you know it is m1 v1 plus m2 v2 by m1 plus m2. Okay. So similar derivations, m1 plus m2. Here you can write m1 dv1 by dt plus m2 dv2 by dt. So here you can write m1 a1 plus m2 a2 by m1 plus m2. So you see, giving similar expression here, acceleration of center of mass is given by what? m1 a1 plus m2 a2 by m1 plus m2. Okay. Now this you can extend for n particles. So for a system of n particles, it will be what? Acceleration of center of mass, it will be m1 a1 plus m2 a2 up to mn an divided by m1 plus m2 up to mn. Now this one also you can we can extend up to in terms of force. Okay. So here this you can write m1 plus m2 up to mn into acceleration of center of mass, that is equal to m1 a1 plus m2 a2 up to mn an. Okay. Now this is nothing but total mass. So this you can write m into acceleration of center of mass, that is equal to m1 a1 plus m2 a2 up to mn an. Now this is nothing but force, external force, ma. So this you can write force, that is F external force, suppose we are applying the center of mass, is equal to m1 a1 plus m2 a2 up to mn n. So this relation also you can remember in terms of force applied at the center of mass. Okay, so total external force applied at the center of mass is equal to what? That is m1 a1, m2 a2, mn an. That is the individual forces acting on the different particles of the system. Okay, so we have derived the expressions for velocity and acceleration of center of mass. Okay, so you see the position vector, the velocity, the acceleration, all are having the similar type of expressions. In position vector you have m1 r1 plus m2 r2 plus m3 r3 divided by m1 plus m2 plus m3. In velocity you have m1 v1, m2 v2, mn vn by m1 plus m2, like that. In acceleration you have m1 a1, m2 a2 up to n divided by m1 plus m2 up to n. Okay, so you can remember these three expressions, okay, for center of mass. Now law of conservation of velocity. Law of conservation of velocity of center of mass. Velocity of center of mass. Okay. So from Newton's law you can write, F is equal to, so F is total external force. So suppose we apply the center of mass, M, A, center of mass. We know that F is equal to MA. Now here it is M, A you can write dV by dt. So dVCM by dt. Now if F equal to 0, if external force equal to 0, means suppose we are not applying any force, in that case m dVcm by dt is equal to 0, or dVcm by dt equal to 0, or Vcm equal to constant. So this is called law of conservation of velocity of center of mass. That means we can say that the total velocity of center of mass always remains constant if no external force is applied. Okay, so you can say that in the absence of external force, the velocity of center of mass always remains constant. That means if we do not apply any external force, in that case center of mass continue to move with the same velocity. Velocity of center of mass will not change. Okay, so this is called law of conservation of velocity of center of mass. Okay, now let me solve some questions from velocity and acceleration of center of mass. Okay, then it will be clear. So first question, that is, suppose two bodies of mass 2 kg and 4 kg are moving towards each other due to their mutual force of attraction. What is the velocity of center of mass? Okay, two bodies of masses 2 kg and 4 kg are moving towards each other due to their mutual force of attraction. What is the velocity of center of mass? So here you see the two bodies are moving towards each other due to mutual force of attraction. Okay, due to mutual force of attraction. That means mutual force of attraction means what? This is the internal forces. That means no external force is applied. So if no external force is applied, then the velocity of center of mass will remain constant. That means here, since no force is applied, so velocity of center of mass, it will be 0. Okay, so this you have to follow, whether they are moving due to some external force or not. If some external force is there, in that case the velocity of center of mass will change, otherwise it will not change, it remains as what? 0. So it is 0. Okay, so let me take another question. Suppose here this is a body and this is a body. Suppose here I am applying a force 12 Newton, and here suppose I am applying a force in this direction 10 Newton, and suppose friction is there. Okay, its coefficient friction here 0.1, here coefficient friction suppose 0.2, means this is friction. There is friction. Its mass suppose your say 1 kg, its mass suppose 2 kg. Now you are asked to find what is the acceleration of center of mass. So you have to find the acceleration of center of mass. Okay, center of mass of these two bodies. So center of mass of these two bodies lying somewhere here. Okay, so we don't require to find the position. You have to find the acceleration of center of mass of these two systems. So here, since you see friction is there, so you know here force we are applying in this direction, friction is opposite direction, so this is the friction. Similar way here, I am applying force in this direction, so friction will be along this. This is friction. So first you find out acceleration of this. Okay. Now what is the net force on this body? Then what is the net force on this body? Find out. So here for 2 kg body, for 2 kg body, what is the net force in the right direction? That is F is equal to 12 minus friction, because this is in opposite direction, so it is 12 minus friction. Now this F is equal to MA. Suppose the first body you consider, so M, say it is A1, you consider A1. Okay. 12 minus friction means what? Mu R. Okay. You will get in law of motion chapter the formula of friction mu. R is normal reaction. So normal reaction here mg. Okay. So this you already got in class in laws of motion chapter. Okay. The formula of friction. So here m is what? 2. So 2a1. It is 12 minus mu is given 0.2. M is 2. G is 10. So it is 2a1. It is 12 minus it is 4. That is 8. So a1 is equal to 4. So a1 we calculate, that is 4. Similarly we find out a2. A2 suppose for this body. So for 1 kg body. For 1 kg body. So here you see, you can write, you take net force. So F is equal to what? F minus 10. Now I have taken F minus 10 because I am taking this direction as positive and this is as negative. Okay. So it is F minus 10. So this F is equal to MA. So you take A2. Friction mu R in minus 10. So MA2 to mu R is mg minus 10. So m is here 1. A2 mu is 0.1 into 1 into 10 minus 10. So A2 is equal to what? A2 is equal to, here it is 1 minus 10, it is minus 9. So we got the value of acceleration. So A1 is 4, A2 is what? Minus 9. Now we apply the formula of, okay, so here we got the value of A1, A2. Now or better you can find out resultant force. Okay. So here you see, in order to find out A1, A2, by finding resultant force you can calculate. You can find out resultant force. Okay. So here you see, it is your F1 you consider. Okay. That is F1. This force, suppose this force you take F1, then you can calculate easily. This you take F1. Okay. So F1 is equal to what? It is 12 minus mu is 0.2, m is what? 2, g is 10. So F1 is what? 12 minus it is 4, that is 8. Here you find out this, take F2, that is mu r minus 10. So mu is here 0.2, it is r is mg minus 10. So 0.2, sorry, it is 0.1, 0.1, m is what? 1, g is 10, minus 10. So it is 1 minus 10, that is minus 9. So we got the value of F1, F2. Now we apply, that is total force. Total force is equal to F1 plus F2. Now total force is nothing but you apply the force on the center of mass. That is, you can write m acceleration of center of mass. Okay. That is here 8 minus 9. Now m is what? M1 plus M2. M1 plus M2. Okay. And this is acceleration of center of mass. It is minus 1. So M1 is here. It is 1 plus 2. Acceleration of center of mass. It is minus 1. Or acceleration of center of mass. It is minus 1 by 3. So this way you can find out the acceleration of what? Center of mass. So just first you find out the individual net forces, then by using the expression total force you can find out the accelerations. Okay.